Dear students, good morning. I am Ramdas. I welcome you to my channel Maths from Basics for You. This is my class number 26. In the previous class, I have taught you derivatives of parametric functions, part 1. So, I have just given an introduction to parametric equations or parametric functions. So today I want to do some problems which are very relevant, very important for examination point of view. So these problems will definitely help you out in examinations, because what I have decided is to first introduce you to whatever topics I am doing it, and later on in the part 2 or in part 1, if possible in the part 1 itself I will finish off some important problems. If not, I will take part 2. In the part 2 I will be doing some important problems, so don't miss my part 2. Because I am selecting some important examination problems which will be useful to you in exams. So without wasting your time, let's start problems on examination problems. So dear students, before I start, I always remind you of my funda: learn maths from basics. I am here to teach you maths right from basics. So dear students, so I need not have to explain you once again what is parametric functions. So straight away we'll get into this. But okay, I will talk to you a little later, because I would like to share some important events, things which has happened as a student, because that will motivate you and that will inspire you. So let's think about that a little later. I will start straight away with the problems. That will be helpful. Don't miss out on this, and try to share these problems to your friends, your colleagues, your classmates, whom all you want to share it, and try to subscribe to my channel. That is very important, because that is my rights. I deserve it, because for my hard work what I am doing I really deserve, and you have to honor it by subscribing to the channel, because it cannot be one-way traffic. So dear students, let's start. In the previous class I have taught you derivatives of parametric functions, and I have done part 1. So today we will take up part 2. So what I have decided is, so if there are good number of problems, if I have to tackle more number of problems, I have no other option but to go for video 1, that is part 1, part 2, part 3. So in the previous class, that is part 1, I have done some problems which are more or less important to you, but in the part 2 I am going to deal with problems which are very relevant and very important for the examination point of view. What I have done is I have selected some questions from textbooks and question papers, and I am trying to work out some problems on the board which will be very much beneficial to you for the examinations. So focus more attention on this and try to learn this, because these are important problems and you can definitely expect these problems in the examination. So henceforth what I will do, in the event if I have a lot of problems to cover, I will do part 1, part 2, if required part 3, otherwise I am happy with part 1 and part 2, and I will be much happier if it is only part 1. But what to do, the problems are more. If I do few problems, it will not be helpful to you. That's the reason I am thinking, let me do more problems so that we are very comfortable in solving problems. So dear students, now we are going to work out problems on derivatives of parametric functions or parametric equations, both are same. So we'll take some important problems and tackle it. Let's see how to solve some important problems. Now example, if you are given find dy by dx if x equals a to e to the power of theta minus sin theta minus cos theta, and y equals a to e to the power of theta sin theta plus cos theta. So here I give you some problem which is based upon parametric functions. So here, in order to find dy by dx, you have to differentiate this with respect to theta. See, if theta is given, you have to differentiate with respect to theta. If you have t here, we have to differentiate with respect to t. Since we have sin t and cos t, etc., so we are going to differentiate this with respect to theta. So what you have to do is, I'll give the procedure. First differentiate x with respect to theta, and later differentiate y with respect to theta. Once you get dx by d theta and dy by d theta, you have to find dy by dx using chain rule. And we know dy by chain rule, to find the dy by dx using chain rule, that is dy by dx equals to dy by d theta divided by dx by d theta. I'll teach you all those things while doing the problem. But what I have found, some students in the examination, they'll get stuck with this. They don't know we have x as well as y, how to go about it. So what they do is, they'll neglect this, they'll differentiate straight away dy by dx and do it. So the problem will not fetch you anything, it will be only a 0, because the procedure is different and they do something. So that is not required. So try to learn this problem according to its merits. So that is very important. I am going to teach you how to find dy by dx, and I have chosen some problems for the examination point of view. Try to learn these problems in depth and try to practice it, because out of this there will be one problem definitely in the examination, and you will be happy to go through that. So let's students, without wasting your time, let's start this. So what we'll do to begin with, we'll differentiate this x with respect to theta. Let's start. So given x equals to a to e to the power of theta sin theta minus cos theta. So once you have this, let's differentiate this. Differentiate with respect to theta. We get what? Dx by d theta equals to d by d theta of a into e to the power of theta. I'll use a square bracket here, into sin theta minus cos theta. So here we have to use product rule, because there are two functions, u and v. You know product rule. I'll teach you once again. D by dx of u and v equals to what? First keep the function as it is, differentiate the second function, that is v, and plus v into d by dx of u. This is product rule. So I am going to use this here. So what I will do, I will take this here outside, because since it is a constant, I will take this, I have to use a product rule here. I will keep e to the power of theta as it is, differentiate this aspect, that is d by d theta of sin theta minus cos theta plus sin theta minus cos theta into d by d theta of e to the power of theta. That's our product rule. Done. So let's differentiate this. This equals a into e to the power of theta. Now if you differentiate this, d by d theta of sin theta will be cos theta, and differentiation of cos theta is nothing but difference rule. So d by d of cos theta is minus sin theta. So this minus sin take this as, and here minus sin theta, close the bracket, again plus. So this is sin theta minus cos theta as it is. If you differentiate d by d theta of, it will be into e to the power of theta itself. So dear students, did you understand this? So e to the power of theta I have kept as it is, d by d theta of this. So if you differentiate, this is nothing but some difference rule. So d by d theta of this, for individual you have to apply. So d by d theta of sin theta will be cos theta, this minus sign. If you differentiate cos theta will be minus sin theta. Done. So I have to keep this as it is v. So I have kept it as it is and differentiate the second function. If you differentiate e to the power of theta, you will get e to the power of theta itself. That is d by dx of e to the power of x is e to the power of x. Whether it is x or theta, you will get the same thing. So I have done this. So what I will do? I will rub this. So now, what happens here? This is dx by d theta on the left hand side. So I will write this dx by d theta, dx by d theta. So I will take this e is common to both. I will take e to the power of theta outside. So that becomes what? A to e to the power of theta, I have taken it common. So this becomes what? Cos theta minus into minus becomes plus sin theta. You have plus sign here, plus sin theta and minus cos theta. Minus cos theta. So you have plus cos theta and minus cos theta. So plus cos theta and minus cos theta cancels. So what happens here? This becomes a into e to the power of theta. So this becomes, we have one sin theta left, one sin theta here and one sin theta. This becomes, you add this, it becomes 2 sin theta. This becomes 2 into sin theta. Therefore, dx by d theta equals to, I take this 2 outside, so this becomes 2 into a into e to the power of theta into sin theta. I call this as equation 1. So dear students, so I will make a note here. What is that? Dx by d theta will be 2a e to the power of theta into sin theta. So this is our equation 1. I will rub this. So now once we have differentiated x, let us take up y and differentiate that d with respect to theta. So we have y equals to a into e to the power of theta. This is sin theta plus cos theta. Again, differentiating it with respect to theta, we get what happens here? Dy by d theta equals to d by d theta of a into e to the power of theta. I will use a square bracket here of sin theta plus cos theta. So use product rule here. So this becomes, I take A outside. So what happens here? E to the power of theta into d by d theta of sin theta plus cos theta plus sin theta plus cos theta into d by d to the power e to the power of theta. So that is equals to what? One more step. This is e to the power of theta as it is. If we differentiate sin x, it will be cos x. Sorry, if we differentiate sin theta, it will be cos theta, plus if we differentiate cos theta, it will be minus sin theta, plus, so this will be what? Sin theta plus cos theta into d by d theta of e to the power theta is, it will be same, e to the power of theta. I will rub this. So I take e to the power of theta is common both sides. I take e to the power of theta common, that is dy by d theta. This is dy by d theta. So this is common. I take e also outside and e to the power of theta outside. So I left it was cos theta plus into minus sin theta plus sin theta and plus cos theta. So in this case, what happens? Minus sin theta plus sin theta cancels. So this becomes what? A into e to the power of theta. This will become the here one cos theta we have, here also we have one cos theta. So if you add, it becomes 2 into cos theta. I'll rub it. Therefore, dy by d theta equals, so I take this 2 outside, 2 into e to the power of a into e to the power of theta cos 2 theta cos theta. I call this as equation 2. So now, once you have got dx by d theta, dy by d theta, you can easily find out dy by dx. How will you find out dy by dx? Use chain rule. What is chain rule? See, I'll teach you what is chain rule now. Chain rule, note. So I'll use chain rule here. What is chain rule? dy by dx equals to dy by d theta divided by dx by d theta. It is also written like this. You can also write like this as dy by d theta divided by dx by d theta. So what happens here, just to cross check it, see both the denominators will get cancelled. If you cancel, you will get dy by dx. This is chain rule. So dear students, you want to simplify this, this will be dy by d theta, denominator goes to numerator, this is d theta by dx. See this. So if you cancel this, you will get dy by dx. This means to say this means to say this. All are same. We can use any of this and do this problem. Preferably I use this, because it will save some space for you and you can easily do it and you won't forget. So I'll use now by using chain rule. We have, it is mandatory to write in the examination what? This dy by dx equals to dy by d theta divided by dx by d theta. You have to write this, otherwise you lose marks. Okay. So now I'll rub this, copy it and rub. Okay, I'll write, okay, I'll rub this. To find dy by dx. We know that dy by dx equals to what? Dy by d theta and dx by d theta from chain rule. This rule is not looking nice. So I will copy this. Dy by d theta is 2ae to the power of theta into cos theta, that is equation 2. So I will rub this. Now dy by dx, what is dy by d theta? Dy by d theta is what? 2a to the power of theta into cos theta divided by 2a into e to the power of theta into sin theta. So we have this cancelled, both will get cancelled here. You are left with cos theta and sin theta. So this is left with what? Cos theta divided by sin theta. Done. That is dy by dx equals to cos theta by sin theta is cot theta. Therefore, dy by dx equals to cot theta. This is the required answer. Here you can write, since cos theta by sin theta equals to cot theta. So dear students, if you can do this much in the examination, you will be allotted 5 marks. You can score 5 on 5. So it's a very simple problem, but you should know the technique to solve it. Prior to this, your formulae plays a vital role. Without formulae, without formulas, you cannot go ahead. So time and again, I repeatedly advise you, warn you to pick up your formulas. That you can get it from my class number 1. So I will go for the next problem. Dear students, let's start with this problem. So we have x equals e to the power of minus t into cos theta and y equals e to the power of minus t into sin theta. Find dy by dx. This is a problem on derivatives of parametric functions. So here this problem looks difficult, but it's not so. But one thing is certain, you need to know the formulas very well. In the event if you are asked to differentiate e to the power of minus t, you should not get stuck, because you can definitely differentiate d by dx of e to the power of x. So e to the power of x is e to the power of x itself. So in this case we have a minus sign. So if you don't know the method to differentiate this and what will be the value of d by dx of e to the minus t, the problem is gone. You cannot proceed. So I am going to teach you. Please try to learn this and try to apply these formulas while doing the problems. So for best results, better memorize all the formulas I have taught you in class number 1. So let's presume that you will definitely learn, and I'll begin. So let's start. So here first I'll take x equals e to the power of minus t into cos t. So what we'll do, we'll differentiate this, differentiate it with respect to t. So just find out whether it is theta or t. If it is to power t or whatever it is, t sin t, it means to say that you have to differentiate that with respect to that parameter itself. So if you are given sin theta, then you have to differentiate with theta, but here we have sin t. It means to say that you have to differentiate with respect to t. What happens here? So this becomes dx by dt equals to d by dt of e to the power of minus t into cos t. So you have a problem with two functions. So whenever you find a problem with two functions, you have to use product rule. So what is product rule? Once again I'll teach you. That is d by dx of u into v. So what it is? This is, I'll keep the first function as it is, as the first function, that is u into d by dx of v plus v into d by dx of u. So this I am giving you as an example. Here you will be thinking, what is this? Sir is teaching me in respect to t, and here all of a sudden he is talking about d by dx. So product rule, I am giving an example. So using this concept, we are going to solve this parametric function with t as a parameter. So I'll rub this. Please make a note and proceed. So what I'll do, I'll keep that. I'll differentiate this. So what I'll do, first I take this e as first function, e to the power of minus t into d by dt of cos t, yes, plus I'll keep cos t as it is into d by dt of e to the power of minus t. So I use that concept. So I'll rub this now. What happens here? This equals e to the power of minus t, d by dx of cos t is minus sin t, so this becomes minus sin t plus cos t, retain it as it is, cos t into d by dx of t. This becomes what? Minus e to the power of minus t. So this minus sign should come. So how it is? Now for example, if you have x to the power of minus n, what you do is minus x to the power of minus n minus 1, isn't it? So this minus n should come. Similarly, in this case, what happens here? This minus n should come e to the power of minus t itself. Okay. Let's simplify this. So what happens here? This becomes minus e to the power of minus t into sin t sin t. This becomes minus e to the power of minus t into cos t. I take minus e to the power of minus t as common. So this is what our dx by dt dt. So dx by dt equals to, I take minus e to the power of minus t common. So this becomes sin t plus cos t. I'll use common bracket. So if you multiply this, you get minus e to the power of sin t, and here minus into plus, it becomes minus, so it's correct. So I'll rub this. That is equals to minus e to the power of minus t into sin t plus cos t. I call this as equation 1. What is this? This is dx by dt. Dx by dt. I'll rub the remaining. That is y equals e to the power of minus t into sin t. So again, differentiating y with respect to t, what we get? dy by dt equals to, I keep e to the power of minus t as it is, and d by dt of sin t plus sin t to d by dx of e to the power of minus t. So this becomes what? E to the power of minus t. So d by dt of sin t is cos t. After differentiating, we get cos t plus, so sin t as it is, into this becomes minus e to the power of minus t. So this becomes what? So I'll take e to the power of minus t as it is. So I'll take this as common. Thus this becomes cos t minus sin t. So if you multiply and see, e to the minus t into cos t, right? So this becomes minus. So you get minus e to the power of sin t. It's correct. So I call this as equation 2. Now to find dy by dx. So to find dy by dx, what you have to do? We have to use chain rule. Whenever you have a problem on parametric functions, so where you will be asked to find d by dx by dt separately, or dx by d theta separately, and again you will have a y function of t or theta, you have separate this as I have done it, and later on you have to find dy by dx. So look at this, you have a different function here, you also have y as a different function. In order to get dy by dx, you have to use chain rule. Please have it in your mind. So to find a solution for parametric function, you have to use chain rule. And what a chain rule is, I'll teach you. We know that dy by dx by dx equals to, what is that? Dx sorry, here this is ulta I have done. You call this as dy by dx, that is dy by dt, dy by dt and dx by dt. So please make a correction there. So what is dy by dt? Dy by dt is what? E to the power of minus t. So I'll use a square bracket. So this is cos t minus sin t divided by, what is dx by dt? Is minus e to the power of minus t into sin t plus cos t. So I'll rub this. I'll put this line here. So dy by dx, that is dy by dx equals to e to the power of minus t into cos t minus sin t divided by minus e to the power of minus t. This is sin t plus cos t. So what happens here? This and this cancelled with the minus, you will have a minus sign here. That is cos t minus sin t divided by sin t plus cos t. So we can do like this. I can change the order of this. So which implies I can change the order of this, that is by rearranging. So this becomes sin t minus cos t divided by sin t plus cos t. What happens here? So if you minus this, you get minus cos, so minus cos t. If you minus this into if you multiply minus sign with cos t, it becomes minus cos t, we have got it. If you multiply minus sign minus, becomes plus sin t, so I have changed this. So it was previously minus cos t minus sin t, now it has become sin t minus cos t. By removing this change, I have taken the sign inside and I have changed the sign. So that becomes sin t minus cos t divided by sin t plus cos t. This is our dy by dx. So I will write this dy by dx equals to this. I rub this. Therefore, dy by dx equals to sin t minus cos t divided by sin t plus cos t. This is our required answer. So dear students, I am trying to work some problems for you. Try to practice it. So we'll go for the next problem. This is the only concept where you can solve any given problem on parametric functions. So it's very simple, provided you know the formula and the method to differentiate. If it is sum rule, use sum rule. If it is a difference rule, you have to use difference rule, parametric function or a composite function, implicit function, whatever it is, apply that and try to differentiate. If you know differentiation, any problem will be simple to you. Otherwise, in the smallest sign also, even if you don't know the formula d by dx of sin x, you can't do it, you can't proceed. So, time and again I have been telling you, try to learn and memorize formulae. That is the important part of differentiation. Without formulae, you cannot survive. Okay, then students, we'll go on next problem. So dear students, I don't say that it is not important, it is important for examination point of view. This is a type of problems you will get for the examination problems. Because the examiner will select some simple problems, but it should look difficult, confusing. So what he does, he selects some problems. So here look at this, if x equals to e to the power of theta, not 0 it is, x to the power of theta into theta plus 1 by theta, and y equals e to the power of minus theta into theta minus 1 by theta, everywhere filled with theta, 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 theta everywhere. What is this theta, sir? We will see what it is. Okay dear students, let us differentiate this. Here given x equals e to the power of theta into theta plus 1 by theta. So here I need not tell you, you have to use product rule. Yes, definitely you have to use the product rule here because you have two functions here and it's very simple. We have to differentiate this with respect to theta because everywhere we have theta. Okay, let's do this. So differentiating it with respect to theta, we get what happens, dx by d theta equals to d by d theta of e to the power of theta, theta plus 1 by theta. So dear students, we will differentiate this with respect to theta. So what happens to this? This becomes first function as keep it as it is, d theta, d by d theta of theta plus 1 by theta plus 1, sorry. So I have to keep theta plus 1 by theta as it is and differentiate d by dx of d by dx of e to the power of theta. So this is how you have to go about it. What happens here? This becomes e to the power of theta as it is, d by dx, sorry, d by d theta of theta is, it becomes 1 plus, I had told you this becomes, I will show you this because it becomes 1 by theta square, it becomes minus 1 by theta square it comes, I will show you. This is d by dx of 1 by x. Remember this, if you differentiate what happens, this is nothing but x to the power of minus 1, that is d by dx of x to the power of minus 1. Here instead of x I am getting theta, so You can, okay, take theta itself. I'll write theta itself because why sir, there you couldn't do it with respect to theta only, he'll tell me. So this becomes theta minus 1. Done. So what happens here? This is, if you differentiate, this becomes minus 1 into theta to the power of minus 1 minus 1. Right? So what happens to this? This equals minus 1 by theta to the power of minus 2, which is also equals to minus 1 by, if I bring it down, it becomes minus theta square 2. So this becomes minus 1 by theta square plus, I'll use common bracket, I don't require square bracket, plus theta plus 1 by theta as it is. Differentiation of e to the power of theta is e to the power of theta itself. So this becomes e to the power of theta. So let's simplify this. So I'll rub this. So I'll take e to the power of common. This equals e to the power of theta common. This becomes 1 minus 1 by theta square plus theta plus 1 by theta. Correct? I have removed the bracket. 1 minus theta square plus theta plus 1 by theta. I'll rub this. What I have to do now, when you get such similar cases, take LCM. So the LCM will be the highest, that will be theta square. So this is equals to, what is this? This is dx by d theta. Keep writing this on the left hand side, even if I forget, you don't forget. Dx by d theta. So this is e to the power of theta. So I put 1, I'll put 1 here also. So theta square is the LCM. Highest will be the LCM. You can take this as LCM. Here 1 goes theta square times. So theta square into 1 is theta square minus, it goes 1 time, 1 into 1 is 1, plus 1 goes theta square. So theta square into theta will be theta cube, plus it goes 1 time, 1 will become theta plus theta. So here theta goes, that is the thing, but you have to divide theta by theta square, that becomes theta. Theta into theta is theta square. So theta was 1 time, so 1 into theta is theta. Understood? So what happens here? This becomes, I'll arrange it in a proper order. That is, first to begin with I'll take theta cube, then I'll go for theta square, then I'll go for theta, then I'll go for minus 1. What is this? This is our dx by d theta. I call this as equation 1. So dear students, I'll write here because the board is not sufficient. I should have written smaller ones. If I write smaller, it's not visible for you. So I'll make a note here. That is dx by d theta is, equals to e to the power of theta into theta cube plus theta square plus theta minus 1. I called it equation 1. So I'll rub this after making a note. So dear students, you have followed this? No doubt, sir. We have followed. So now what we'll do? Like good children, we'll differentiate this y with respect to theta. So now we'll take up y. Now y equals e to the power of minus theta Sir, the problem actually starts here, sir. We don't know what is e to the power of minus theta. I am here, no? Hum hai na? Main hu na? So this is theta minus 1 by theta. Okay, dear students, let's see now. We'll differentiate this. Once again, same old product rule. Done. Now, differentiating with respect to theta dy, the moment you see theta is understand it is differentiated with respect to theta itself. So equals to dy d theta of e to the power of minus theta into theta minus 1 by theta. So now it is clear. D by d theta means you are differentiating with respect to theta itself. So what happens here? This is, I keep this e to the power of minus theta as it is, d by d theta of theta minus 1 by theta plus theta minus 1 by theta into d by d theta of e to the power of minus theta. This is what is your problem. Very simple it is. Let us see. So what happens here? This is equals to e to the power of minus theta. Okay, into d theta by d theta is 1. So this again becomes minus 1 by theta square. So minus into minus becomes plus. So this becomes 1 by theta square. Sir, we didn't follow, sir. Please explain once again. Yes. So we have d by dx of d theta, I take d by d theta of minus 1 by theta. Okay. So what I will take this minus value, I take it outside, minus d by d theta of 1 by theta square. That's theta square. Oh, sorry, theta. How it has come, I am teaching you. Okay, theta. So what happens here? Theta. So this is nothing but minus d by d theta of theta to the power of minus 1. Done. So this becomes minus, I will write this, differentiating this, minus 1 into theta to the power minus 1, correct? So this is nothing but minus and keep it outside. So minus into minus becomes plus. So theta minus 2, that is equals to plus theta square. So it became plus. So this minus into minus becomes, because you have taken minus sign outside, so it becomes plus. So it becomes plus 1 by theta square plus theta minus 1 by theta. So this is differentiation of e to the power of x is e to the power of x into minus. Now what you do is, you take this as this d by rub this. Now you have understood this, we'll take this. So we will take this one, d by d theta of e to the power of minus theta, isn't it? So this is nothing but, can I write like this? E to the power of minus 1 theta, can I write like this? It is not 10, it is theta. Minus 1 theta. Done. So what happens is, differentiation of e to the power of x is e to the power of x itself. So this becomes as e to the power of minus 1 theta into coefficient of that becomes minus 1. So what happens to this? This becomes minus e to the power of minus theta. So this becomes what? Into minus e to the power of minus theta by rearranging it. So this becomes what? E to the power of minus theta, I will use a square bracket only. This becomes 1 plus 1 by theta square. I will take the, instead of this, I will take this minus e to the power of minus theta into theta minus 1 by theta. I have brought it here. Okay. I'll rub this. Yeah. What is common? E to the power of minus theta is common, that is dy by d theta equals to e to the power of minus theta is common. So I have taken this becomes 1 plus 1 by theta square. So this becomes minus theta, because this goes here, you will have minus into theta is minus theta. So minus into minus plus 1 by theta, plus 1 by theta. I will rub this. So again take LCM. This is e to the power of minus theta. So once again we will have theta square, this becomes 1. So 1 goes theta square times, so theta square into 1 is theta square, plus it goes 1, so I take 1 minus sign into theta is theta cube plus theta. So what happens, let's rearrange this, that is equals to e to the power of minus theta, that is minus, okay, minus theta cube plus theta square plus theta minus 1 by theta square, because LCM, sorry, here I forgot to add, put this divided by that LCM theta square. See, somehow we miss. If you were to be there in front of me, your third year theta square is missing, you have told me, but now I am correcting it, no problem. So this theta square, this is plus 1, sir, was plus 1, so minus theta cube plus theta square plus theta and plus 1. So this is our dy by dt, dy by dt, d theta is this. So note this is our equation 2. So let's rub this. Now dy by dx equals to what? Dy by d theta divided by dx by d theta, that is by chain rule. Rule is not, doesn't look like rule only. Chain rule. So now what I will do, first I will write dy by dx, that is equals to minus, that is e to the power of minus theta into this minus theta cube plus theta square plus theta plus 1 by theta square. So this is our, that is equation 2 divided by equation 1. By equation 1. So we are dividing this equation 2 divided by equation 1. So I will rub this now, dy by dx, this dy by d theta is got, this is our equation 2 divided by, we got divided by e to the power of theta, that is theta cube plus theta square plus theta minus 1 divided by theta square. What happens here? Theta square cancels. So dy by dx. Now dy by dx equals to what? What I will do is I will send this e to the power of theta to the numerator. Then what happens? This becomes e to the power of minus theta into e to the power of minus theta. Once it goes, it becomes e to the power of minus theta only. Divided by, what is this? This is, I will rearrange this because to begin with minus sign I don't like. So I will bring first theta square. By rearranging theta square plus theta, I will arrange this. Theta square minus theta cube plus theta plus 1 divided by, here also theta square plus theta cube plus theta minus 1. So what happens to this? The powers are the bases are same, add the indices. So I will rub this, I will write here. I call this as equation 3. Equation 3 becomes what? Equation 3 becomes what? dy by dx equals to e to the power of minus 2 theta. So this becomes 1 theta minus 1 theta minus 1 theta becomes e to the power of minus 2 theta by theta square minus theta cube plus theta plus 1 divided by theta square plus theta cube plus theta minus 1. Therefore, I can write this itself, one line you write therefore dy by dx equals, repeat this, okay. This is your answer. So your problem was with how to differentiate e to the power of minus theta. So I am showing you the way, because most of you get stuck when you are differentiating d by dx of e to the power of minus theta. I have seen when correcting and associate, most of them they go and do some silly mistakes and they will not end up in doing completing the problem. They leave it as it is, something all they do, they will not. Out of 10 people, hardly 2 or 3 persons will do this problem. So remaining just they leave it off. So very simple problem, anybody can do this. So dear students, I have shown the way. So any problem given to you on e to the power of minus theta has to be solved using this technique only. There is no other way. Okay, dear students, let's go for next problem. So dear students, here we are asked to find dy of dx if x equals to 1 minus t square divided by 1 plus t square and y equals to 2t plus 2t divided by 1 plus t square. You won't believe me, this problem had come, I have done this problem in my examination. So when I was doing my BE, first year BE, that time the same problem had come to me, the same, I had got the same problem and I did this problem. So it was very interesting, very easy it is. So here you have to do this problem using quotient rule, because whenever you get y equals u by v or x equals whatever it is, if you have numerator as denominator, definitely you have to go for quotient rule. So if you use quotient rule, you can easily solve this problem. So let's proceed. So now let's take x equals, given, I'll write little above so I'll get some space. Given x equals 1 minus t square by t square by 1 plus t square. So we have this problem differentiating with respect to theta, with respect to t. So differentiating with respect to t. See, if they are given you t, differentiate with t. If they are given you theta, differentiate with respect to theta. That's a hint for you. So what happens here? So dx by dt equals to d by dt of 1 minus t square by 1 plus t square. So this quotient rule, you all know what a quotient rule is. That is d by dx of u by v. This is a quotient rule, and I am going to give the solution so that when I am doing it, you should not get confused. So what happens here? This is equals to what? To differentiate this, what you have to do? Take the denominator square, that is v square, and later on keep the denominator v as it is, keep the same thing as it is but not square v, and d by dx of d by dx of u. So u first function, then minus keep u as it is, d by dx of v. So this is a quotient rule. So we'll use that and try to bring this v square at the center so that it looks neat. Supposing I write here, it looks dirty, odd, so bring it to the center. So when you practice, try to practice this. Minus and below that it should come. It looks neat, because who knows, you're going to be an engineer. So as an engineer, you should know to plan, work your plan, plan your work, work your plan. So plan your work and work your plan as an engineer. Okay, dear students, I'll take this. What I'll do? This is equals to denominator square 1 plus t square the whole square. So here, that is, I'll keep this 1 plus t square as it is, and d by dx of 1 minus t square minus, then keep 1 minus t square as it is, 1 minus t square as it is, and d by dx of 1 plus t square. So somewhat it comes to center, no issues. So how do we go about this? So this is, I'll take this equal sign equals to, so this is equals to, I'll write this one plus t square the whole square. So this 1 by t square as it is, differentiation of 1 minus, this differentiation of 1 is 0, minus, that is minus 2t minus 1 minus t square, again d by dx of 1 is 0, and this will be into 2t. Let's simplify this. So I'll rub this, I'll rub this too. So what is this? This minus, I'll rearrange it into 1 plus t square minus 2t into 1 minus t square divided by 1 plus t square the whole square. I'll rub it. Dx by dt. equals to, so multiply this, so this becomes what, minus 2t, again minus 2t cube, minus 2t, minus into minus plus, so this will be 2t cube by 1 plus t square the whole square. So what happens here, you have minus 2t equals to minus 4t, so minus 2 cube and plus 2 cube cancels, so you have 4t divided by 1 minus 1 plus t square the whole square. You follow this? So I have multiplied minus into this, minus 2t becomes minus 2t, minus into plus becomes minus, that becomes 2t cube, 2t into t square, 2t cube. Now I will take this, minus sign is there, minus into this becomes again minus 2t, and this minus into minus becomes plus 2t into t square, that becomes plus 2t cube, minus into minus becomes plus. So here you have minus 2t becomes minus 4t, you have minus 2t cube plus 2t cube cancels, you are left with minus 4t by 1 plus t square the whole square. I call this as equation 1. We take y, y equals to 2t by 1 plus t square. So again use quotient rule to solve this. So dy by dt will be what? dy by dt will be one plus t square the whole square. I will take 1 plus t square into d by dx of 2t minus 2t into d by dx of 1 plus t square. So I will copy this here, dx by dt is minus 4t by 1 plus t square the whole square. I will rub this. This is our equation 2. Equation 1. So I have taken this, we will solve for this. Again I will rearrange so that we will differentiate this. That is dy by dt equals to 1 plus t square, d by dx of 2t is, so 2, this becomes 2 minus 2t into d by dx of d by dt, sorry, somewhere I will go some small mistakes. Dt, okay. So 2t into this will become again 2t divided by 1 plus t square the whole square. I rub this. So let's multiply this. This equals 2 ones are 2 plus 2t square minus 4 t square divided by 1 plus t the whole square. This is our dy by dt. So here you have plus 2t square minus 4t square. So this becomes what? This becomes 2 plus 2t plus 2t square minus 4t square. So it becomes minus. So this becomes minus 2t square by 1 plus t square the whole square. Did you understand? We have plus 2t square minus 4t square. So you subtract now. So that becomes minus 2t square. This 2 you have as it is. So divided by this. I rub this. So what happens here? What is common here? So I'll take dy by dt equals to, I'll take common. 2 is common, that is 1 minus t square by 1 plus t square the whole square. So this is our equation 2. Just make a note. I'll rub this. Therefore now dy by dx equals to what? Dy by dt divided by dx by dt. I'll rub this. I'll rub this too. So what is our equation? By chain rule, dy by dx equals to dy by dt and dx by dt. Both are same. Either you can write like this or you can write like this. So this, so which is nothing but what is dy by dt? Dy by dt is here, that is 2 into 1 minus t square by 1 plus t square the whole square divided by what is dx by dt? Dx by dt is minus 4t. I'll write that minus value, that is okay. I'll write minus, you should not get confused, minus 4t by 1 plus t square the whole square. So what I'll do, I'll simplify this. That equals to this denominator, both the denominator gets cancelled. You have left this minus n is there. I'll take that minus n here. That will be 2 into 1 minus t square. So 2 is gone there. So we have, okay, we'll write one more step, divided by 40. Done. So this goes 2 times. This is equals to 1 minus t square. This minus sign is there. Minus 2 into 1 minus t square by 4t. So 2 ones are 2 twos are. So that is equals to what? Minus 1 minus t square by 2t. That is dy by dx equals to minus 1 minus t square by 2t. So I want to avoid this minus value. What to do is, how will you avoid this minus value? I'll show you how to do it. So this can be written as, take the minus, you can write this as t square minus 1 by 2t. Either you can stop at this or one more step you can do. Okay, see here, minus into minus, minus into plus minus 1, you got this, minus into minus plus t square. So both are same. To avoid this minus sign, I have changed it. A minus b equals to, a minus b not equals to b minus a concept. Okay, therefore I love this. Therefore dy by dx equals to t square minus 1 by 2t. This is the required answer. So dear students, so this problem looked complicated, but it's not so. It is very easy. Every problem, as a matter of fact, every problem is simple, provided you know the procedure, the method and the formulae. Without this combination of these three, you cannot proceed. So repeatedly in every class I have been telling you to memorize formulae, otherwise it will be difficult, you cannot proceed. So dear students, see, when I was a student in one of the class, when the teacher was teaching, he asked me a question. So that particular day it was thing, I had some appointments outside with my family. I forgot to revise it. The next day I went and sat coolly like a good student, very honestly, first bench. I used to always sit in the first bench. And I used to be so alert, lecturers used to like me a lot. But that was my bad luck. That day was my bad luck. So he asked me a question. I could not answer him. He asked me, Ramdas, please get up, walk out. If you're not prepared for the classes, please don't come. And he sent me out. Believe me, after that I never committed a mistake. Because I love maths, I loved maths, and I will love maths. Because maths makes you perfect, intelligent, sharp. So don't ignore maths. Any day, this is my favorite subject. Okay, students, let's go for the next problem. We have a problem here. dy by dx. Find dy by dx if x equals to sin theta into root of cos 2 theta and y equals to cos theta into root of sin 2 theta. So we have to find dy by dx. So dear students, more or less this problem is similar to whatever we have done earlier. Here we have to find dx by d theta because he has given you theta. So dx by d theta, and by here we have to find dy by d theta. Once you find dx by d theta and dy by d theta, you have to find dy by dx. Without finding these two, you cannot get into dy by dx. So what we have to do to find dy by dx? We have to use chain rule, which I have already taught you. So without wasting much time, let's start. So here, what happens here? We have given x equals to sin theta into root of cos 2 theta. So we have to differentiate this with respect to theta. So use product rule because we have function of we have two functions here. We have to use product rule. So by differentiating with respect to theta, we get what? Dx by d theta equals to what? D by d theta of sin theta into root of cos 2 theta. So let's use product rule. I have taught you product rule once again for those who have joined late. So of u into v will be what? First keep as it is d by d theta of V plus keep V as it is d by d theta of u. So we are going to keep the first function constant, differentiate other function later on, plus keep the second function as constant and differentiate the first function. This is product rule. So we will use this concept to solve this problem. So what happens here? So first step, this equals to, I keep sin theta as it is, then d by d theta of under the root cos 2 theta plus under the root cos 2 theta and d by d theta of, I'll rub this, d by d theta of cos theta, sorry, sin theta. So d by d of sin theta. So first function. Now let's simplify this. Sin theta. So this becomes half into root of cos 2 theta into d by d theta of cos 2 theta plus this is cos 2 theta into d by d theta of sin theta. So I will rub this. So what happens here? Dx by d theta equals to, so this is sin theta, half, I will write this, below this only I will write 2 into cos 2 theta, d by d theta of cos 2 theta is minus, this will be minus sin 2 theta into 2 plus under the root cos 2 theta, d by d of sin theta is cos theta, this becomes cos theta. If you differentiate d by d of sin theta is cos theta. I rub this. So let's simplify this. So what happens here? I will write this first. This equals to minus 2 into sin 2 theta into sin theta. I have written this first. I take this minus sign divided by 2 into cos 2 theta plus under the root cos 2 theta into cos theta. So here this 2 and this 2 cancels. I will rub this. So what I do here, I don't want this, somewhat I have an allergy to minus values because I don't want to see negative things. So I will try to bring it on the right hand side, I will rearrange it. So this can be written as what? This is dx by d theta. So now dx by d theta equals to, first I will write this, that is cos 2 theta into cos theta minus sin 2 theta into sin theta, and here we have, below this we have this what, cos 2 theta, right? So what I'll do is, now I'll take LCM because we have to take LCM. So what happens here, what is LCM here? So below this I write 1, so this becomes what? So under the root of cos 2 theta we get it as I have taken as LCM, this is our LCM. So here 1 goes root under the root cos 2 theta, it goes under. So multiply this with this, what happens here? This becomes, this is cos 2 theta into cos 2 theta, that is cos theta minus sin 2 theta into sin theta. See here, I did not have to write, I could have easily written, I would have removed this root, straight away I could have written cos 2 theta. But some students are weak to understand, it will be difficult for them to pick it up. That's why it goes one time, that is the root of cos 2 theta. So one time into this cos 2 theta, that becomes what? Root x into root x becomes cos 2 theta. Next step I'll write that so that you'll understand. So what happens here? This is cos 2 theta. So root x into root x equals to x. Likewise, root of cos 2 theta into root of cos 2 theta becomes what? Cos 2 theta into cos theta minus sin 2 theta into sin theta. I'll rub this. So, don't you think this reminds you of what? Don't you think this? Here we have cos 2 theta into cos theta minus sin 2 theta into sin theta. Don't you think it reminds you of cos A cos B minus sin A sin B? Yes, it is cos A cos B minus sin A sin B. What is cos A cos B minus sin A sin B? It is cos of A plus B. So we know that cos of A plus B equals to, I'll write little still this side, note, cos of A plus B equals to what? Cos A cos B minus sin A sin B. Here A equals 2 theta and B equals theta. Remember this. So what happens here? So I write this little nearer. So dx by d theta equals to this. Okay, I'll rub this. Now I call this as equation 1. Equation 1 is of the form cos of A plus B, that is dx by d theta equals to, I can write this as cos of 2 theta plus theta by cos 2 theta. And what is this? This is nothing but cos of 3 theta by under the root cos 2 theta. I'll rub this. I call this as equation 2. Done. Okay, I'll write this. Somewhere I'll make a note. Now dx by d theta equals to what? That is cos 3 theta by under the root cos 2 theta. I'll write this, please make a note. Done. Now dx by d theta is over. Now let us find out what is dy by d theta. We have y equals to cos theta into sin 2 theta. So use product rule to differentiate this. What happens here? By differentiating with respect to theta, we get what? Dy by d theta so dy by d theta equals to d by d theta of cos theta into sin 2 theta. So use product rule here. So what happens here? Which implies that is nothing but cos theta into d by d theta of under the root sin 2 theta plus sin 2 theta into d by d theta of cos theta. Cos theta. So what happens here? So dy by d theta equals to cos theta. This becomes half into, we keep as it is, sin 2 theta into d by d theta of sin 2 theta plus under the root sin 2 theta into d by d theta of cos theta. So I rub this. Now dy by d theta equals to, so I write this below this. So this is cos theta by 2 into under the root sin 2 theta. If you differentiate sin 2 theta, we get cos 2 theta into 2, cos 2 theta into 2 plus under the root sin 2 theta. If you differentiate cos theta, we get minus sin theta, minus sin theta. So let's solve this. So this equals to dy by d theta. I take this 2 into, I take this 2 here, 2 into this cos 2 theta into cos theta by 2 into sin 2 theta. I'll take this minus value, minus into plus minus, so this becomes sin 2 theta into sin theta by 1. So this two cancels. I'll rub this. I'll take LCM, that is sin 2 theta is LCM, dy by d theta equals to so under the root sin 2 theta. So this goes one time. So this is what? Cos 2 theta into cos theta minus. So this goes one time, that is under the root sin 2 theta, root of sin 2 theta into this. So this becomes what? Sin 2 theta into sin 2 theta into sin theta into sin theta. Why I wrote this is because I don't want you to get confused. So this one goes here, sin 2 theta times under the root sin 2 theta. So sin 2 theta into this sin 2 theta becomes the sin 2 theta into sin 2 theta out LCM into this sin theta. So sin 2 theta under the root sin 2 theta into under the root sin 2 theta becomes sin 2 theta. So how? That is root x into root x equals to x. Similarly, so after division it goes, one goes under the root sin 2 theta, that sin 2 theta into this sin 2 theta. So that becomes, if you want to next step I'll show you. I rub this. Now dy by d theta equals to cos 2 theta into cos theta minus sin 2 under root sin 2 theta into sin 2 theta becomes only sin 2 theta, sin 2 theta into sin theta divided by under the root sin 2 theta. So what happens here? I rub this. Now, as in the earlier case, we have found this is something unique. This is cos 2 theta into cos theta minus sin 2 theta into sin theta. So what does it reminds you of? Cos A, cos B minus sin A, sin B. Right. So this becomes cos of A plus B. So earlier we had dx by d theta was what? That is cos of 3 theta by under the root cos 2 theta, right? So now what happens to this? I call this as equation 3. Equation 3 is of the form cos of A plus B, where A equals 2 theta and B equals theta. So I'll rub this. So that is dy by d theta equals to what? Cos of 2 theta plus theta divided by under the root sin 2 theta. So this is nothing but cos of 3 theta by under the root sin 2 theta. Done. I'll rub this. Now you have found out dx by d theta, which was dx by d theta was cos 3 theta by under the root divided by under the root cos 2 theta, and dy by d theta is cos 3 theta by under the root sin 2 theta. So what is dy by dx? That is dy by d theta divided by dx by d theta, that is by chain rule. So I'll rub this. To find dy by dx, you have to find dy by dx. I rub this. Now by chain rule, dy by dx equals to what? Dy by d theta divided by dx by d theta. So now dy by d theta equals to cos 3 theta divided by root of sin 2 theta. I'll rub this. Okay, that is dy by dx, that is dy by dx equals to, what is dy by d theta? Dy by d theta is cos of 3 theta divided by under the root sin 2 theta divided by what was that? That was cos of dx by theta is cos of 3 theta divided by cos of 2 theta. Cos of 2 theta. So what happens? Cos 3 theta cancels. We are left with what? Cos 2 theta divided by sin 2 theta. How it goes about it? So don't directly write sin 2 theta by cos 2 theta, is wrong. This is denominator of the numerator, and this is denominator of the denominator. So this has to go to the numerator. For example, if you have a by b divided by c by d, this is nothing but a by b into d by c. Suppose you call this as a, you call this b, c, and this is d. So a by b is a gets cancelled, a and c gets cancelled, you are left with b by d. So you have to get b by d. Done. So what happens to this? I rub this. So this left with this. So what is under the root cos 2 theta by under the root sin theta? I write this one more step. Can write this e further equals to under the root cos 2 theta divided by sin 2 theta. Yes. So what is that? Cos 2 theta by sin 2 theta is nothing but cot 2 theta, cot theta, that is nothing but cot 2 theta. So I will write here, that is, once again I will write dy by dx equals to, we have got under the root cos 2 theta by sin 2 theta. I am rewriting it. So what happens to this? This becomes under the root cot 2 theta, that is dy by dx. Therefore dy by dx equals to under the root cot 2 theta. This is the required answer. So dear students, it's a tricky question, very interesting. So you have to practice once again. So even though you know the formula, even though you know the formula and the method, procedure, you have to work this problem once again, others will be difficult for you and you get stuck in the examination. This is one of the examination problem only. Whatever I am doing in part 2 is all pertaining to examination questions or most probable questions for examination. So we will do one more problem. Just add a square root for this because I had forgotten to add a square root. Cos 2 theta by sin 2 theta is cot 2 theta, the square root of cot 2 theta. So I have already done the same problem here, so need not have to worry about it. So we will go for the next problem. So dear students, trigonometry is nothing but we have to play with it, we have to manipulate. So I will tell you, among all the mathematical subjects, I prefer trigonometry because it is very, very unique. Like you will be juggling with it. So I will be doing trigonometry shortly because I want to teach you this. You will be really delighted to go through this. So after this, let's go to next problem, because the more I speak on this, I will be wasting my time, because I believe in action rather than speaking. So let's do next problem. So dear students, we have another problem, very interesting problem. Looks complicated, it's not so. If this problem is given to you in the examination, you might be wondering how to tackle this problem. Here I have told you, if you have anything to the power, take log on both sides, right? The moment you take log on both sides, the problem is solved. But here we have e to the power of cos 2x. How to solve this, I will teach you. Let's start. So given x equals to e to the power of cos 2 theta. The moment you see theta, you have to differentiate with respect to theta. You had seen cos 2t, then you have to differentiate with respect to t. Now it is theta, so differentiate this. Taking log on both sides. Taking log on both sides. What happens here? That is log x equals to cos 2 theta. See, whenever you have an exponential, something exponential to the power of something, so when you take log, you have to straight away take this. Don't write log e. Anyway, log e to base e is 1 only. So, but in this case, what happens here? The moment you take log for exponential, straight away whatever is in the as a power in the power, take that directly. So log x equals to cos 2 theta. Now differentiate this with respect to theta. 1 by x into dx by d theta equals to d by d theta of cos 2 theta. So this is equals to what? If you differentiate cos, it is minus. So this is minus sin 2 theta into 2. Therefore dx by d theta equals to what? This x you send it there, this becomes minus x into sin 2 theta. I will write this 2 also here. So this becomes minus 2x into sin 2 theta. So this x he multiplies this by cross multiplying here. So by cross multiplying we get this minus, we have this 2 this x into sin 2 theta. So this is our equation 1. So we will go for equation 2, that is y equals to e to the power of, I will take it a little below, I will write a little below, y equals e to the power of sin 2 theta. Similar way this becomes log y equals to sin 2 theta by taking log. So this becomes what? 1 by y into dy by d theta equals to cos 2 theta into 2. I told you this sin of, if you differentiate d by dx of sin ax, it will be cos ax into a. So similarly this becomes cos becomes sin 2 theta into inner verse function, you have to write that. So what happens is, so this becomes dy by d theta equals to 2y into cos 2 theta by chain rule. Dy by dx equals to what? Dy by d theta by dx by d theta. I love this. What is dy by d theta? That is nothing but 2y into cos 2 theta divided by dx by dt is this minus 2x into sin 2 theta. This 2 cancels. So dy by dx equals to minus y by x, this is cos 2 theta by sin 2 theta. What he wants, I will rub this. We know that given x equals to e to the power of cos 2 theta, that is log x equals to cos 2 theta. What is cos 2 theta here? Cos 2 theta is nothing but log x. Also y equals e to the power of sin 2 theta. Therefore cos 2 theta equals to log x and log y equals to sin 2 theta. Therefore sin 2 theta equals to log y. We will substitute values for cos 2 theta and sin 2 theta. That is equals to minus y into what is cos 2 theta? Cos 2 theta is log x and sin 2 theta is log y, that is x into log y. So you make a thing here, dy by dx equals to minus, so you get minus y by x log x into log y. This is the, therefore dy by dx equals to this answer. We'll go for the next problem. Here we have an interesting problem which is an important from the examination point of view. If I was given an opportunity to set a question paper on parametric function, definitely I would have selected this question, because this question is very interesting and very tricky, and if you have good knowledge about parametric functions, this is a question for you. So this question definitely would have selected. Very interesting. Watch it. Here x equals to under the root a to the power of sine inverse t, and y equals under the root a to the power of cos inverse t. Show that dy by d equals to minus y by x. So here, the moment you see this problem in the examination, some of the students, I am sure they will not attempt to this problem. They just ignore it because they feel it complicated. Definitely they will not select. I will tell you, at least 50 to 60% or 40 to 50% will not attempt this problem. If they are extremely intelligent who are competing for ranks, only they will prepare for such, or they will anticipate such questions in the examination. But a normal person will just ignore it. So dear students, it is very simple. You cannot ignore this. If you know what all I have taught you, like sum rule, difference rule, product rule, quotient rule, then implicit functions, parametric functions, composite functions, you should be able to do this problem. Otherwise, it is not worth that you have learnt it. So dear students, very simple. The moment I show you the technique, you definitely know it's such a simple problem, you wouldn't have attempted this. So let's do this problem. In your interest, I want to do, because I want to prepare you for such eventualities, such questions in the examination. So the problem is very simple. Let's do it. So students, here he has given x equals under the root a to the power of sine inverse t. So what is the best way to tackle this problem? So what you do is, you negate such problems, you take to the power of half. I tell you how it is. See, what is root x? Nothing but square root of x is nothing but x to the power of half. So I will use this concept to solve this problem. So what I will do is, can I write like this? X equals a to the power of sine inverse t to the power of half. Can I write like this? Yes, very much. So now you are able to differentiate this, because now it has come to standard form. This was not in standard form, but now it is a standard form. So I will show you, this is of the type a to the power of x to the power of n, right, where n is half. So you can easily solve this. So here, now differentiating with respect to, this is t, we get what? See, dx by dt equals to d by dt of a to the power of sine inverse t whole to the power of half. Now you can do this. So if you differentiate, what do you get? This is nothing but, this is d by dx of x to the power of n is what? Nothing but n into x to the power of n minus 1. Done. So I will use that concept. What happens here? This becomes half into a to the power of sine inverse t to the power of half minus 1. Half into a to the power of sine inverse t half minus 1 into d by d theta of a to the power of sin inverse t. So what is d by dt to the power of, see we have one more, that is d by dx of a to the power of x. This is of that type, a to the power of x, where x is sin inverse t. This is of this type. What is the solution for this? This is nothing but a to the power of x log x log a to base c, right? So I have to use that concept here. So what I'll do, I'll rub this. So what is this? This is our dx by dt. Now dx by dt equals to half we have, that is half, this is a to the power of sin inverse t to the power of half minus 1 is minus half. This becomes minus half into d by d. What is this? So this becomes what? A into sin inverse t log a to base c and d by dx of sin inverse t. See this. After doing this, again you have to differentiate that. So here let us see, for example, if you have to differentiate this, what happens? A to the, that is a to the power of log a to base c into d by dx to the power of x. This is nothing but 1. So that's the reason we are not using. But here in this case, we have to differentiate sin inverse t also. What happens here? So I'll rub this. I'll rub this too. Okay. This is that is dx by dt equals to half. I'll take outside. So this is a to the power of sin inverse t to the power of minus half into a to the power of sin inverse t log a to base c into d by dx. This will be 1 minus t square d by dx of sin inverse x equals to what? Under the root 1 minus under the root 1 minus t square. So yes, sorry, it's the x square. This is the formula I am writing. So this becomes 1 minus x square. So I use that concept here for sin inverse t will be under the root d by dx 1 by under the root 1 minus t square. So I use that formula. See, formulae, wherever you go in differentiation, it will not leave you. It will follow you like a shadow. So be strong with your formulae. That's all I can advise you, not more than that. So dear students, adopt this. Let's solve this. This is equals to 1 by 2. I will bring this here itself. This will be 1 minus t square. I will take it outside. So this becomes a to the power of sin inverse t to the power of minus half into a to the power of sin inverse t. I will write it to the power of 1. I will take this to the power of 1, okay, into log a to base c. Okay, now here the bases are same I'll add the indices. Done? I'll rub this. So bases are same. So dx by dt equals to half into 1 minus t square. So what happens to this? A to the power of sin inverse t to the power of minus half plus 1 into log a to base c. I rub this. So what happens here? That is dx by dt equals to into 1 minus t square. So this becomes a to the power of sin inverse t. So this becomes half minus half plus 1 is half. You get plus half into log a to base c. I'll rub it. So what I do is I'll simplify this. This is half into under the root 1 minus t square. I'll write this. What is this? This is a to the power of sin inverse t. Half I'll put it as bracket. So I have taken this root x equals to x to the power of half, x to the power of half, or x to the power of half can be written as root x, right? So here we have a to the power of sin inverse t, a to the power of sin inverse t to the power of half. I can write this as a to the power of sin inverse t within root, done, into log a to base c. And what is this? Half into 1 minus t square. This becomes nothing but x into log a to base c, since x equals under the root a to the power of sin inverse t. So I substitute this value as x because x equals under the root a to the power of sin inverse t. So that's the reason I replace this entire value with x. Done. So what we wanted? We wanted x, we have already got it. This is how you have to approach. Done. So what I'll do? What is x? So I'll make a note of this. Here dx by dt equals to equals to 1 by 2 into 1 minus t square into x into log a to base c. I have made a note there. I love this. Please make a note. Any doubt? Please once again cross check it. So now we will go for y. And y equals under the root a to the power of cos inverse t. Do this from the similar grounds only. Now this will be, that is y equals a to the power of cos inverse t to the power half. So I removed this root, I put half. Now you can differentiate it. Differentiating with respect to t, we get what? dy by dt equals to what? So this of the type x to the power of n. So this becomes half into, I'll put a bracket, a to the power of cos inverse t to the power of half minus 1 into d by dx of a to the power of cos inverse t. I'll rub this. So what happens to this? This equals to half into e to the power of cos inverse t. This becomes half minus plus half minus 1. So this becomes minus half. And what about this? This becomes a into cos inverse t log a to base e into d by dx of cos inverse t. So you have to differentiate even the inner function. So I'll rub this. Let's simplify. dy by dt equals to half a to the power cos inverse t to the power of minus half into a to the power of cos inverse t. I'll write it as to the power 1. So I can write this as to the power 1 into log a to base e. Now d by dx of cos inverse t, that is d by dx of cos inverse x equals to minus 1 by under the root 1 minus x square. So remember, whenever we have something to do with c, that is cos theta, cot theta or cosecant theta, we'll always have a minus value. Don't forget this. I have been telling you right from the beginning when I was doing problems on video on, that is formulae. So in class 1 I have given you a list of formulas, please go through that. So d by dx of cos inverse x is 1 minus 1 by under the root 1 minus x square. So what happens here? Into minus 1 by under the root 1 minus t square. I'll rub this. So what happens here? I'll bring this here itself. So that equals to half into 1 minus t square. So a to the power of cos inverse t to the power of minus half into a to the power of cos inverse t to the power of 1 into log a to base c. So I'll write little below, you'll get confused. So what I'll do is, this is half, I'll bring the t square here, 1 minus t square. This is a to the power cos inverse t to the power of minus half into a to the power cos inverse t. I'll write it within 1. So I'll write this log a to base c. Dear students, will follow this. So we have a minus value, you take that minus value here, equals to minus, what is this? Dy by dt. dt. So this minus value we have, so take this minus value. This minus sign I have taken it here. I rub this. So dy by dt equals minus half into 1 minus t square. See, the bases are same, add the indices. So this becomes a to the power of cos inverse t to the power of minus half plus 1 into log a to base c. I rub this. So dy by dt equals minus half into 1 minus t square. So this becomes a to the power of cos inverse t. So minus half plus 1. So minus half plus 1 is plus half into log a to base c. I'll rub this. This dy by dt equals to minus half into 1 minus t square. So this becomes what? I'll write this under the root a to the power of cos inverse t. Since x to the power of half equals to root x, so this half I removed it and I put this within the bracket. But what is this? A to the power of cos inverse t. A to the power of cos inverse t is nothing but your y into log a to base c. I rub this. Okay, I'll rub this. Sorry, I rubbed it off. Okay, so this is nothing but minus half into 1 minus t square under root a to the power of cos inverse t into log a to base c. I rub this. This is our dy by dt, isn't it? So what is this? Can I write like this? This can be written as minus half into y log a to base c, since a to the power of cos inverse t equals to y. See this, a to the power of cos inverse t is nothing but y. Y equals a to the power of cos inverse t. So I have substituted that. So this is our dy by dt. To find dy by dx. So we are going to find dy by dx. So once you have got dx by dt and dy by dt, using chain rule we can easily find dy by dx. So by chain rule we have, I read this, we have there only, we have dy by dx equals to dy by dt by dx by dt. So what is dy by dt? dy by dt is minus, I will write like this only, minus half y into log a to base e divided by, and what is that? That is half, here we have one t square by under the root 1 minus t square y into log a to base e. So dear students, please make this correction. So here also I write this. So what is dy by dx? That is nothing but minus half into under the root 1 minus t square y into log a to base e divided by half 1 minus t square into x log a to base e. Done. So what happens here? This cancels, this and this cancels, you are left with minus y by x. I rub this. So you are left with what? Minus y by x. What do you want? dy by dx minus y by x. So you got minus y by x, we already got it. So therefore dy by dx equals to minus y by x. Hence proved. Dear students, if you can do this problem independently without seeing this notes, without seeing this, so for that you need to practice, and once you have practiced, if you do this individually without anybody's support, believe me, you have learnt differentiation, because this problem involves many things. So whatever I have taught you, that will really come into play, it will help you a lot. So don't neglect any of my subtopics what I have taught you in differentiation, that is sum rule, difference rule, product rule, quotient rule, then parametric functions, implicit functions, parametric functions, composite functions. This will make you strong in differentiation. So if you are strong in differentiation, you will be strong in integration too, because same concept, formulas also more or less same thing. What only thing, for example, in differentiation d by dx of sin x is cos x, but whereas in integration of sin x will be minus cos x. So you will know little things will be changing. So dear students, this problem is really very interesting and only inspire you to do. Once you learn these problems, how to do it, you will start loving mathematics. So dear students, let us stop here, and I will try to finish part 2. If you require part 3, I have some more problems, I can do it, but I think this is more than enough. With part 1, the slight mistakes in the beginning regarding how to find a table, please make that correction, because by oversight it has happened. So if you watch the video for some more time, that correction has been restored and I have done it correctly. So by oversight it has happened because I did not divide that by denominator, that's the reason it has gone wrong. So please try to correct that and follow my full video, you'll get it. So dear students, this finishes part 2 of parametric functions. If you are interested, and if you in the comment box, if you write, if you want some more problems, definitely I will do it, provided you give in the comments. Otherwise, I shall stop parametric functions. I'll switch on to successive differentiation, because that is very important. So once I do successive differentiation, you will be prepared for partial differentiations. So we later on will see nth derivative, Leibniz theorem, all those things we will do, and switch on to other topics. So dear students, I will stop here before I forget. So please share my video, like my video, and subscribe to my channel. That is very, very important. Without that, I will not be motivated. So don't you think I deserve to have a subscription? I deserve, and you need to subscribe to my channel, because I really have put hard work in teaching to you. So students, it's your duty and it's my rights, and I deserve it. Please subscribe to my channel. With this, I end parametric functions here. Only I'll be waiting for your comments. If you want, I'll do part 3. Otherwise, part 1, part 2 is sufficient. So I have tried to cover most of the important problems pertaining to examination. So most probable questions are there in this for the examination. If they give any problems on parametric functions, definitely this video will help you. So let me end here. So dear students, thank you. Good night. Take care. God bless you. Bye.